So, good day everyone. My name is Penusan Nabil Huda. I would like to share my skills in origins. I would like to share my skills in linear regression fittings. In settings, this analysis can be used in many aspects, but today I would like to share in the adsorption kinetics. So, let me share my screen. Okay, as presented in the screen, this is my data from the pseudo second order model plotting. So the x-axis is the time in minutes, and the y-axis is the t per qt in the pseudo second order. So if you reach or if you find the equation in the second order model, the y-axis is presented as t per qt. So I would like to analyze the CBA-ACT and CBA-DZ with linear regression. So we can determine whether the best regression has been reached in both of the materials, whether it's in CBA-ACT or CBA-DTC. So the first step is that you have to block the tables or the area that you want to analyze, and then click the plot settings. I suggest the symbol in scatter settings. So the black dot is presented as CBA-ACT and the red dot is presented as CBA-DTZ. So there. After that, you click in the dot everywhere. Just click everywhere in the dot, and then click analysis, and then click fitting. In the linear fitting option, you have to choose the open dialog. Okay, then choose the recalculation with manual settings. So you can choose the options of the data will be presented. In the fitting options, just let it be. And in the quantities to compute, you can analyze the ANOVA 2 in here. And the another settings, just let it be just like they are. In the regular options, and all other parameter is not changed at all. And then click OK. And then you can obtain the calculation from the origins. So the parameter we obtain from the calculation is the intercept and the slope, and also the calculation of the standard error on here. You can obtain it too. So in the linear regression using pseudo second order models, the slope is presented as the k, or the constant, kinetic constant of the pseudo order second model, and the intercept is just like the intercept. So we obtain the adjusted R square in the lead A is 0.99463, which is lower than the lead B, but it's in the still in the scope of the 0.99, which is I can say that it's a good fitting. So we can back to the graph. The graph has been presented as the tables in here with the calculation. This is if we look in the books in the fit linear tab. This is the full chart of the analysis. But in the graph, we can obtain the simple view of the analysis. So because we choose the linear fitting, so the equation will be y equal to a plus b times by x, which is the a is intercept and b is the slope of the equation. So we can obtain the adjusted R square or the adjusted R square in here, which is the values of the lead A on here is lower than the lead B. Lead A is referred to the CPA-ACT and lead B is referred to CPA-TTZ. So from this calculation, from this simple calculation, we can summarize that the CPA-DTZ has a better fitting compared to CPA-ACT based on the adjusted R square, which is the R square of the CPA-ACT is lower compared to the CPA-DTZ. But it's still a good fitting for the two of materials. That's for today. I hope this explanation is clear. So thank you for watching and good luck.